Introduction to Scaling Networks. Objectives. Explain how switch networks support small and medium-sized businesses. Understand the convergence of data, voice, and video-affected switch networks. Describe the benefits of creating networks based on a structured hierarchical design model. Enumerate the two most commonly used Cisco hierarchical design models. Identify the layers found in the Cisco hierarchical design model. Identify which form are available. Explain how does layer 2 switches build and uses MAC address to forward data. Differentiate the collision domain to broadcast domain. Scaling computer networks. Businesses can grow along with their needs in terms of user, uptime, speed. Their network must be able to do the same. A computer network designed to accommodate the need for growth is called scalable. Enterprise network needs enterprise hardware specifically designed to provide reliability through redundancy and failover, but nothing can replace a properly designed network. First need of a proper design, the traffic must be organized so that it doesn't unnecessarily propagate through the network at the cost of bandwidth. We achieve this through a hierarchical design composed of 3 layers: bottom to top, access distribution, core. Each layer has a specific function. The access layer is in charge of providing connection to the final user in a local network. The distribution layer forwards traffic from 2 different local networks. The core layer is a high-speed backbone between distribution blocks, that is, networks that are geographically dispersed. Crucially, use traffic start at the access layer and it's not passed to the upper layer unless their functionality is required. In a small enterprise network, distribution and core layers can be collapsed into a single one, reducing cost and complexity. This is the core layer, distribution layer, access layer, hierarchical design model. This is sample. Cisco architecture. Cisco advised this network design principle that divides network into modular components, maintaining the 3 layers. Its module includes enterprise campus, enterprise edge, service provider edge, remote. The enterprise campus includes access distribution and core layers. The entire enterprise infrastructure will belong to this module. In the access layer, L2 and LT3 switches provide port density and links and or trunks to the distribution layer of the building. Distribution layer aggregates these links or trunks with L3 devices that provides routing, access control, and QoS. The core layer provides very fast connectivity between distribution layer modules and the enterprise edge modules. This enterprise structure. Enterprise campus can have additional sub-modules such as server farm module, data center module, service module. This module provides networks monitoring and a unified control of services such as wireless controlling or telephony services. The enterprise edge includes module that connects the enterprise to remote resource through the service provider network, internet connectivity, VPN tunnels, and wireless access network. Wide access network. The service provider edge provides service through a service provider such as an internet connection and phone lines. Each of these services has corresponding edge device in the enterprise that examines all packet, decides whether it should be allowed on the enterprise network. Failure domain. A failure domain is the area of the network that is impacted by a problem of failure. Much of the impact of a failure domain is determined by the functionality provided by the faulty device. When a problem occurs, smaller failure domains reduce the impact of the problem, simplify troubleshooting, and thus decrease downtime. Reducing fair domains in the main core is expensive, so designers concentrate on prevention, making sure network effort affects smaller area and distribution layer is easier. Distribution devices. L3 switches or routers are usually deployed in pair with access device evenly distributed. This is called switch block. Switch block act independently of the others. This is the example of failure domain. Tips for scalability. Use modular devices can easily expand their capabilities. Some devices are more easily deployable in cluster that simplify management and configuration. Use these modular devices in a tree network design. Think about IPv4 or IPv6 addressing strategy that will accommodate future users. Readdressing later could be a major disruption. Use routers and L2 switches to limit broadcast and filter traffic to the core. Use redundant link between network device, link aggregation, such as Cisco Ethernet channel, methods include bandwidth with more expensive media channel. A scalable routing protocol that minimizes the size of routing table. Redundancy is all about minimizing the chance of single point of failure. One easy method to achieve redundancy is by installing duplicate equipment, at least for critical devices. Redundancy also means redundant paths that traverse the network. Redundancy in switch could cause traffic loops at L2, spanning tree protocol, is a mechanism that prevents them. STP disables redundant paths until those paths are necessary, for instance, in the case of failure. Ethernet channel. Multiple traffic link between access and division switches will need to converge in a single outgoing link that could become a bottleneck. It is possible to tie multiple physical links together in a single logical one, increasing available bandwidth. This is called link aggregation. Ethernet channel is a Cisco protocol that uses ports of existing switches to create logical Ethernet channel interface. Every configuration is done on an Ethernet channel interface, ensuring consistency between ports. Ethernet channel can do load balancing between the links that are part of Ethernet channel interface using several methods. Wireless connectivity. Wireless connectivity is crucial in expanding a network because it increases flexibility without excessive cost. Implementing wireless connectivity requires a very minimum, a wireless and IC for end devices, an access point, or wireless router. Wireless connectivity needs careful planning. Several things must be considered, among them: types of device, coverage, interference, security, speed, and protocols. Tuning routing protocols. OSPF supports a two-layer hierarchical design or multi-area OSPF. All OSPF networks begin with area 0, also called backbone area. As the network expanded, the other non-backbone areas can be created. All non-backbone areas must be directed connected to area 0. Switch platforms. Cisco has 5 categories for enterprise switches: campus LAN switches, cloud managed switches, data center switches, service provider switches, and virtual network switches. Enterprise switches comes in several form factors: fixed or modular configuration, stackable or non-stackable. For switches that are mounted in racks, thickness is important. It is measured in rack units. These are the most common parameters that need to be evaluated when choosing a switch solution: cost, port density, power specification, reliability, port speed, frame buffers, scalability. Port density is the number of ports available on a single switch. High port density switches allow better use space power, Consider a single 48 ports versus dual 24-port switches. Then scale the average to network made of 1,000 end devices. Modular switches can support extremely high port density through multiple expansion cards. Catalyst 6500 switches can support more than 1,000 ports. Link aggregation reduces available for something less of an impact with modular switches. Forwarding rate means how much data a switch is able to process per second. Wire speed is the data rate a single port of switch is able to obtain. It can be 100 Mbps, 1 GB, 10 GB, or even more. If forwarding rates are too slow or too low, switches cannot reach full wire speed of all their ports at the same time. Access layer switches are limited by their uplink speed to the distribution layer anyway. So they don't need to have a high forwarding rates, reducing cost at the distribution and core layers at the high forwarding rates as much as greater impact of overall performance. Power over Ethernet. Power over Ethernet can provide the power of device needs to operate the same Ethernet cabling used for data transmission. Power over Ethernet allows flexibility because it means a device can be installed any place reached by Ethernet cable. Power of Ethernet capable switch are more expensive, so it's need to be evaluated carefully if PoA is needed or not. Some Cisco switches are also support PoE pass-through, which allows powering the device in cascading fashion, starting for an upstream power source. Multi-layer switching. Multi-layer switch have the ability of building a routing table. Support several routing protocol, forward IP packets nearly at the same L2 forwarding speed. They are able to do that thanks to specialized ASIC processor and routines. The trend is clear. The cost of supporting routing in switch is decreasing. Soon all switches will be supported. Routing requirements. Routing is an essential components of distribution layer. Without a routing process, packets cannot leave the LAN. Router provides several functions. Selection of the appropriate paths of the traffic, translation between different media types and protocols, broadcast containment, connect remote location, group user logically, provide enhanced security. There are three categories of Cisco routers: branch routers for local routing and one access, network edge routers, it is for boundary routers designed for multi-one deployment, and last is service provider routers designed for service provider who wants to differentiate their services. Router hardware. Router can have many form factors, from small desktop router to rack or blade models. Router can be fixed. The desired router interfaces are built in and not expandable. And modular. The router has slots through which is impossible to change the interface or adding new ones. Managing iOS files and licenses. Cisco has single operating system, iOS, for the most of their products. iOS comes in many versions. And for a single version, it has many different images with different feature sets. These feature sets are customizable by user when a product is purchased. A new device is shipped with an image pre-installed that corresponds to the customer's specified package and with permanent license for it. In-band versus out-of-band. There are two methods of connecting a Cisco iOS device for configuring it or monitoring it: in-band and out-of-band. Out-of-band is used for initial configuration and every time a network connection becomes unavailable. It requires direct connection to the console port as well as in terminal emulation client. In-band management is used for normal maintenance and configuration, and it works over working network connection. It requires at least one network interface active, connected, and operational, as well as SSH telnet, or HTTP access to the device. Thank you.